Have you ever wondered why moving a smaller object is easier than moving a larger object? Newton's second law states that acceleration is directly proportional to the net force applied on the object, and is inversely proportional to the mass of the object. Let's look at how net force and acceleration are related. The greater the net force, the greater the acceleration. The smaller the net force, the smaller the acceleration. Acceleration is directly proportional to the magnitude of the force. Let's look at how the mass of an object influences its acceleration. Consider two objects, a bus and a car. For a given net force, which one will accelerate more? We know it's the car because the car has a lower mass than the bus. Therefore, the greater the mass of an object, the lower the acceleration, and the lesser the mass of an object, the greater the acceleration. Therefore, the acceleration is inversely proportional to mass of the object. Acceleration, A, equal to F over m. Or force is the product of mass and acceleration. F is the net force or resultant force. And m is the mass of the object. We now understand that force, F, equals ma, unit of mass is kg. And the unit of acceleration is meter per second squared. Therefore, the unit of F is kg meter per second squared, which is equal to 1 Newton. Named after Sir Isaac Newton. 1 Newton is the force required to cause a mass of 1 kilogram to accelerate at a rate of 1 meter per second squared. Did you know? A person who is walking or running applies Newton's third law instinctively. When we walk, we push backward on the ground, so that the ground pushes us forward, thus making us to walk forward. Newton's third law states that each force of action has an equal and opposite force of reaction. Consider the boat. The boat exerts a force on the water, and the water exerts an upward buoyant force on the boat. This follows Newton's third law of motion. I hope you now have a clear understanding of Newton's laws of motion. Thank you.